A radical expression is not simplified if there is a radical in the denominator. The fact the square root of a times the square root of a is a can be used to rationalize a denominator when it contains a single radical term. The first example is 1 over the square root of 2. Now to rationalize this, let's multiply by the square root of 2 over the square root of 2. This is another name for 1. So this will simplify to square root of 2 over, now the square root of 2 times itself is 2. And we're done. Another expression, 6 over the square root of 8. Now instead of multiplying by the square root of 8 over the square root of 8, let's simplify the square root of 8 first. So we end up with 6 over 2 radical 2. Now, there's a couple different routes you can take here. Let's simplify 6 over 2. 2 goes into 6 3 times. So we're left with 3 over radical 2. To rationalize that denominator, we'll need to multiply by the square root of 2 over the square root of 2. So we're left with 3 radical 2 over 2. And there's now a rational number in the denominator. Next example, well, let's involve some variables. So we'll have the square root of 3x over the square root of y. To rationalize that denominator, we need to multiply that by square root of y over the square root of y. So we end up with our radical sign 3xy over y. And that's as simple as we can get. You cannot divide the y's because one is under a radical and one is not. Now let's look at a cube root. 1 over cubed root of 3. Now to rationalize that, we can't just multiply the cube root of 3 by another cubed root of 3. Because if we do, we end up with the cube root of 9, which is not a perfect cube. So we're going to have to multiply by another cubed root of 3. We end up with cubed root of 9 over the cubed root of 27, which simplifies to cube root of 9. 9 is a perfect square, not a perfect cube, over 3. Now there's another way you can do this as well. Let's rewrite the expression. 1 over the cubed root of 3. Now instead of multiplying by the cubed root of 3 2 times, you can just multiply once by the cubed root of 9. And the reason is because 3 times 9 is 27, so we have our perfect cube. So we still have the cube root of 9 on top. We have our cubed root of 27 in the denominator, which simplifies to 3. And then we have our cube root of 9 on top. So you can see we get the same answer either way. The last example will be another cube root. How about 1 over the cubed root of 4? Now what do you need to multiply 4 by to get a perfect cube? Well, 4 times 2 is 8, and 8 is a perfect cube. So let's multiply by cubed root of 2 over cubed root of 2. Numerator is cubed root of 2. The denominator will be cubed root of 8, and 8 is our perfect cube. So denominator simplifies to 2, and then we have cubed root of 2 on top.